Assalamualaikum everyone, welcome back. So today we are going to cover the topic silicon micromachining. So what is silicon micromachining? Silicon micromachining is a process of fabricating microscopic component inside of the silicon substrate or on top of a silicon substrate. So this process enables the rapid process of MEM technology, and some of the example of the product is like beam, diaphragm, groove, orifice, spring, gear, and hinge. Okay, so the picture below shows some example of the product. There are two types of silicon micromachining. One is what we call as bulk micromachining, and another one is surface micromachining. Let us see the bulk micromachining process first. Okay, so what is bulk micromachining? So bulk micromachining is the etching pits, trenches, or all the way through the silicon wafer to make mechanical structure. So meaning that in bulk micromachining, the process involves etching into the silicon substrates in order to get the final product. So the microstructure are formed by selectively etching away the bulk of the silicon wafer so that you can achieve the desired result. Some processes involved in this bulk micromachining are like wet etching, plasma etching, rise and dry, and etch stop technique. Here are some characteristics of the bulk micromachining. So for the structure thickness, the range is from sub-micrometer to several hundred micrometer, or even the full wafer thickness also is possible. Another one is lateral size. It can go to millimeter or sub-millimeter in dimension. Here is the example of the bulk micromachining process. So the first one is the diffuse layer. For example, here is P-type silicon is diffused on the substrate, and then mask is placed on top of the substrate, like the one that you see in here, the purple color, and then the etching process will start in this area. So then the area here will be etched away. So then there will be one freestanding cantilever here. So this is the product, the final product that we want to see. So now we see the surface micromachining process. So surface micromachining process is a process to build the structure by depositing the thin film layer by layer on the surface of the substrate. So first, there will be a thin film layer on the surface of the substrate, and then layer thickness is usually around 2 to 5 micrometer, and it can be up to 20 micrometer for some special cases. And this process employ film of two different materials. So there are two type of material. One is structural material, that the final one, the final material that we want to use. Another one is what we call as sacrificial material. So this sacrificial material is will be etched away, and then we'll release the final structure that we want. So the more layer, then the much more complex the structure will be, and of course it will become more difficult to fabricate. So in surface micromachining, there are several techniques will be employed. One is sacrificial layer techniques, IC technology, and wet anisotropic etching, and also plasma etching. In the sacrificial layer technology, usually two different material will be employed. One is structural material, and another one is sacrificial material. So for example, polycrystalline silicon, or we call as polysilicon, will be used as the structural material, and another one is silicon oxide is used as the sacrificial layer. Here is the example of fabrication of cantilever beam. So for example, here there will be a deposit the pattern oxide on the surface, which is the silicon oxide, and then the next one is they will be depositing the pattern for polysilicon, okay, so that you will get the final product. And then last one is they will etch away the one here, the silicon oxide on the surface of the substrate, so then it will leave the final product like this. So this is how it will look like in the real one. Why is the pair of polysilicon and silicon oxide is widely used in the sacrificial layer technology? So here are some the following is the reason why poly Si and also SiO2 is a desirable pair. So first one is polysilicon and silicon oxide is widely used material in the IC industry. So the knowledge about how to deposit and how to remove the material is already available. Okay, so next, silicon oxide can easily grown by using the low pressure CVD process, which is not really costly, so and it also quite easy to be performed. And then for silicon oxide, it can be etched away by using the hydrofluoric acid, so that and it also not will not affect the polysilicon, so it's easier process. Okay, so polysilicon has excellent mechanical properties and it can be doped for other electrical and mechanical properties. That's why polysilicon is used. So meaning that polysilicon and silicon oxide is a good pair in terms of the sacrificial layer and also the structure layer. So what is sacrificial layer actually? So sacrificial layer, for example, the silicon oxide is utilized to develop the desired structure. So usually it support the product, the final structure that we want to fabricate. It does not constitute any part of the final device, meaning that it will etch away after we already get the final product that we want to produce. The sacrificial layer technology processing step is quite simple. It is the first one, you have to deposit the silicon oxide sacrificial layer on the silicon substrate, and then patterning of the silicon oxide, and then deposit of polysilicon film, and then patterning. And another one is after that you just remove the silicon oxide layer under the polysilicon layer by any suitable etching process. Now let us see one example. If let's say you want to fabricate this lever, let's say this lever like this on the silicon substrate. So let's see how the process will be done. Let's see the first one. So we have the silicon substrate, and then the next process that you have to do is to put the silicon oxide on the surface. So once the silicon oxide layer is deposited on the Si substrate, next process will be deposit the silicon layer on top of the silicon oxide substrate, the silicon oxide layer. Now, after that, patterning of the polysilicon layer will take place, meaning that some part will be etched away, and then finally etching the silicon oxide layer so that the final product can be achieved. So here another example on how polysilicon cantilever encode directly to the silicon substrate. So here is the example of the final product. Now let's see the step how the process will take place. So the first one, let's say this is a silicon constraint base with the layer of the oxide. So then what you have to do is placing the mask 1 for etching process. So then you can etch away the oxide layer over here. After the first process of etching, then the second mask will be placed, and then the deposition for the poly Si will be performed here. So then this is the polysilicon layer that already placed on the the silicon oxide layer. Okay, so after the the deposition of the polysilicon is done, so then the silicon oxide layer will be silicon oxide here will be etched away and leaving the final product like this one. Let us see another example. For example, this one is polysilicon chamber. So the green color is silicon polysilicon. Okay, so that it create the chamber inside on the Si substrate. So let's see how the process will take place. So now let us see the process. The first one, you are going to have the silicon substrate, and then there will be deposition of silicon oxide layers through selective deposition. Okay, so that only this area will be deposited. Okay, and then there will be deposition of the silicon polysilicon layer on top of the oxide layer, and then you will do the pattern of the polysilicon, so meaning that there will be a part where you are going to etch away or and finally you etch away the silicon oxide layer, then leaving the final product of polysilicon chamber. In surface micromachining, there are some issues that need to overcome. For example, there are adhesion of layer, interfacial stress, and also stiction. This is the example for the adhesion layer. If you can see from the picture for B, it's looking into how a good adhesion, a good connected of the material together. But for B example showing the adhesion where the sacrificial layer and also the adhesion layer is not sticking together, making it an error to the final product. The next one is stress. So if you can see into the picture here, there are some compressive and also tensile stress on the surface of the product, the structural material. So if the compressive stress involved on the structural material, after the removal of the oxide, uh, the beam, let's say for lever here is going down. If it is a tensile stress on the surface, so it going up. So if you can see the example shown in the picture below. The last one is stiction. Stiction also we can say it is sticking plus with the friction. So stiction is the static friction that need to be overcome to enable relative motion of the stationary object in contact. Okay, so let's see the origin of the stiction. So here is where the stiction the origin of the stiction. So as the liquid solution gradually vaporized, the trapped liquid exerts surface tension force on the microstructure, pulling the device down. So this one is showing the chemical container where the etching material is placed inside here, and also this is the beam that we want, cantilever beam that need to be produced. So due to the trapped liquid inside below this area, below the cantilever beam area, so it make the surface tension force, and then can form permanent bond by the molecule force when they are close. So this one is they cause the sticking and also friction in between this area. Okay, so that's the end of our class today. So let's see you in the next class. Assalamualaikum.